Hi, Stuart here. Yet another video on cloud patterns. Today we're going to tackle containers and paths. So again, same disclaimer. This is what I've done that works for real customers in the real world along with my company Magenic. So this may not work for your particular use case. Use cases are important. We want people to think about what their use case is before they solution. Again, these are my biases based on real projects. I like things that just work. And I wanted to put in a special pet peeve about containers. I love containers, but your code must be this good before you put it into a container. It has to be 12-factored. It has to be stable. It has to be reliable. And you should think of a container as being an electron microscope of every flaw in your code. So what do we have to do to become container ready? Basic code quality things. I've got some videos on those. Stabilization things, right? We get to stability how? By load and stress testing our code, seeing what broke, deciding if the scenario we tested is a legit one for our use case. Because sometimes some testing organizations like testing things to destruction and then complaining they destructed, which is inoptimal. What you really need to do is test things to the actual use case that you think you're going to have. Number of transactions, number of concurrent users, whatever, and then a skosh more to figure out where you're at. You want to be 12-factor ready. We have a whole series of videos on 12-factor. And you want to make sure that your team gets training not only in cloud things, but in container things. And then you want to build some proofs of concept, and you want to incrementally move things into containers, and you want to do the deployments. And then you want to validate that things work as you expect by testing again. So that's kind of the overall flow for containerization. We have a much longer video on this that you can go watch. Here is the scenario for running in containers on Azure Kubernetes services in Azure. Those of you who watched the first Cloud Patterns video will recognize the bones of this. What we have done effectively is swap out the PaaS hosting in this example for AKS. And I'm going to drill into some important differences in a minute. We still have the opportunity to use Azure Service Bus as an intermediary to functions. We can still do attached storage and SQL and other things. We have our networking tiers, right? We have our web application firewall. We have a CDN that is going to be a facade over our blob storage, which holds our SPA and all its assets. That's a very cheap way to host a UI. And the SPA is going to make web service calls going through the network security tier to a load balancer through Apogee. And then it gets into the container bits, which we'll come back to in a minute. And again, we have divided things into sort of 4 or 5 big layers, right? We have the cold, cruel world. We have our, for lack of a better word, network DMZ, where we set up protections for the things inside. We have our intermediate tier, which in this case includes Apogee, blob storage, AKS. So we would have, in our containers, we would have our web services and other things. We can put functions in there too, it turns out. But in this case, I've preserved as much of the original diagram as I can. And then we have our stateful tier with storage, SQL, other types of things. And then, of course, in the back, we have our administrative tier where we have our reporting and other things that are internal. You can also have Power BI, obviously, facing forward to the internet, so you can publish reports and things, and then use Power BI's role-based security along with Active Directory, and you can control access to whom can do what. In this case, I'm showing it as being a back-end thing. Let's talk about what makes AKS and indeed container systems from a high-level architecture point of view, right? We have other videos on Kubernetes and its internals and on containers and how they work. There's lots of great material from Microsoft up on YouTube. There's lots of great material on Channel 9. There are lots of great material by other authors. But I wanted to talk a little bit about how containerization fits into our overall goal of being fit for use and fit for purpose. So fit for purpose is obviously our business requirements, functional and non-functional. And fit for use is about the abilities, operability, and so on. And we have videos about that. 12 Factor essentially is trying to give some prescriptive guidance about how to get to the abilities through adopting some cloud and indeed enterprise best practices. But the advantage that we get when we move to containers is threefold. The first advantage is densification, which is a fancy way of saying that for the same unit of computer power, I can have more running processes. And that's because containers are built up in layers and they run on top of a container runtime. And although the walls between containers are thinner than the walls between virtual machines or things that are hosted in PaaS potentially, the advantage is that we can get very high densities because typically we build containers with no fluff. We start with an operating system layer that is absolutely stripped down. An example of that would be Alpine, but you can also get other Linux and Windows distros that are specifically intended to be the bottom of the well in a container. We add to those only what we need and nothing else. The layers can be shared in the runtime without commingling processes or data, and that also allows for densification. And so it's a very efficient way to get the most out of a fixed set of computing resources. The second thing that containers do is they offer up the opportunity to do new kinds of architecture that in theory you could do in other ways, but is a tremendously easier to do. One is fabric computing. Azure has a native fabric computing layer. It is notoriously hard to get to work, but the Kubernetes community has come up with solutions like Istio that allow you to take a lot of the reliability engineering and make it the problem of the Istio layer that sits on the container runtime and permeates your Kubernetes cluster. We can swap in and out in a modular way the elements that make up Kubernetes. Kubernetes is a series of services. And so we can swap out our auth. And in fact, the Microsoft implementation of Kubernetes leverages Azure Active Directory, which is, the principal source of authentication and identity in Azure. So the fact that they could do that very quickly by swapping out parts of Kubernetes and making it specialized is a benefit. And the third thing I think is most significant is that container startup and shutdown is significantly better. And what this allows you to have is auto-scaling with a lot better responsiveness. Because container startup and shutdown lifetimes are so short, you have the ability to dynamically scale on the same set of infrastructure depending on the loads as they travel through your system, right? Because sometimes you have a lot of load over here, and other times over here is not so loaded up, but there's opportunities for loading over there. So letting Kubernetes scale the number of instances based on the load is excellent. And in many ways, the behavior of Azure Functions is very similar in that regard. And you pay as you go. But the other advantage to AKS is a degree of heterogeneity at which you can do that. So you can set very fine-grained policies on when to scale things. you can set up Kubernetes to literally reconfigure based on changes, right? So Kubernetes is the ultimate soft configured environment. The side effect is, though, coming back to your code must be this good, is that number 9 in our 12-factor list, disposability, becomes critical. We need to spend extra effort to make sure that units of work execute all the way through or fail in obvious ways so that person invoking the unit of work or the system invoking the unit of work knows it didn't succeed and can try again, which means that you have to have a certain amount of respect for the saga pattern. In other words, compensation. You need to be able to take workflows of any size or number of steps and break them down into small pieces so that you can have restartability. And again, that also allows you to have granular control over essentially compensating for transactions that failed because the container they were running on stopped existing because it got scaled. The built-in networking mechanisms in Kubernetes attempt to manage the risk of that by stopping traffic to things that they intend to scale down. But the timelines are pretty short. And so I've seen customers take processes that run on orders of minutes and not tell Kubernetes that, in fact, this is a long-running process, durable process, or a process with persistence, and then be very unhappy when there's loss of state. The other thing about Kubernetes that's a side effect of all of this is the pluggability allows you to have control over how data flows not just in and out, ingress and egress from your controllers and your clusters, but also networking within the Kubernetes cluster itself. So everything else is a series of trade-offs. Here's an example. In the previous example with Platform as a Service and Platform as a Service app hosting, we had Redis Platform as a Service because we identified that we wanted a shared state, and we wanted that shared state to be available to all of our microservices and functions and whatever that we're running. And we also wanted it to have differential state, but across all members of the same type. So, for example, my payroll processing module might have its own shared state or cache of data that it uses. In Kubernetes, we have the option of taking a lot of these things, marking them as persistent containers, and you could run Redis inside AKS as on containers. There are other things like RabbitMQ and other technologies that have containerized versions. What you have to carefully consider, however, is are they truly container native implementations? In other words, will they be well behaved as they scale? Will they interoperate with the Kubernetes runtime in such a way that they're trustworthy, that they are reliable, that they are durable, and so on? And in many cases, people have gone to, for example, Docker Hub and seen, wow, this thing's as a Docker container, I could run it in my Kubernetes. And you absolutely could. It will run. But will it run durable? And so you have to be very careful about that, because a lot of things that get containerized are there so that you can quickly experiment with things, but they're not intended to be used that way in production. So, for example, in the last video I did around trying to get to reliability, my demonstrations for how to get reliability in .NET Core sat on top of SQL Server for Linux. And for convenience, I wrote some scripts that booted up my demo database into a Linux container and ran it locally on your local Docker. And that's great for demo purposes or for development, for developer isolation. These are all great things to have. Would I run SQL Server in a container in production? The answer is probably no, if for no other reason than I don't think it's there yet. And I want a lot more fine-grained control and durability to my SQL instances, and so I would probably stay with Azure SQL Server Platform as a Service. And you could say the same for storage and whatever. So just be aware that there are trade-offs here, and not everything that's available in a container is suitable to run in production. Here's a list of off diagram things, and you can drill into these. These are things that I think are sort of indispensable